All right, let's take a look at lesson 1.4, measuring angles. All right, let's go through a couple definitions here first. An angle is formed by two rays with the same endpoint. Those rays are called the sides of the angle. The endpoint is called the vertex. So the vertex in this angle right here is going to be vertex A. B and C are on the sides of the angle. Now, the sides of the angle of this ray would be considered to be called ray AB and ray AC. But they both have A in common, therefore that tells you where that vertex is. Now, there's several ways you can name it. Okay, you can name an angle by its vertex, which this is the easiest way. Vertex A. This is angle A. But not every time can you call it by just its vertex. For instance, there may be more than one angle at a vertex, so you have to be a little more specific. And the way we do that is we do it by using a point on each ray and a vertex, such as angle BAC. B, A, and C. The vertex should always be the middle letter. Now, we can also switch this up because there's no certain way you have to start and stop, so we could say this is CAB. Notice in both of these, the vertex A is in the middle. And the last way, if possible, is going to be by naming the angle 1. This does not mean it's 1 degree. This is referring to just angle 1. We may have multiple angles at one place, and so therefore you may have a need to call it different angles by just numbers. We always put the angle 1 in the interior. We also would label its degrees in the interior as well. Exterior would be the outside of the angle. So let's look at example 1 on how we name the angle. So what are two other names for angle 1? Well, angle 1 is talking about going from here, I'll do this in different color here so it's a little bit easier to see. That's referring to this distance and this distance. It's opening up from here to here. Angle 2, it opens up from here to here. So in this case it asks, what are two other names for angle 1? Well, we cannot just call it angle M because there are three angles here at the vertex M. We could have this angle 1, angle 2, and then the entire angle of JML is located here at the vertex M. They all share the same one. So the second one way to do it is by saying angle JMK. J to M to K. That talks about this angle measure here. The other way to do it is to just reverse the letters. It would be K. M still has to go in the middle, and then we end at J. That tells me I'm starting here, going to the vertex, going here. I'm talking about the angle in between. Okay, so make sure you pay close attention to why we can't name it by just angle M, because we're not sure which angle it's referring to. All right, you guys try the next one. Let's look at part 1, part A, or part B. What are two other names for angle KML? So pause the video, write those down, and then come check your work. All right, the two other ways, we could call this angle 2 because it's referring to the measure from here to here. And we could also use the name angle LMK. So we could go the opposite direction here. So this is still referring to this angle right here in blue. How far this ray is from this ray. How far does it open up? Now let's look at classifying angles. These are some that you should know, probably from middle school and possibly from elementary school. Acute angle. This is an angle that's formed from 0 degrees to 90 degrees. Whenever you see the degree symbol, that tells you how many degrees are in that angle measure. So this right here is an acute angle. A right angle, it's always recognized by its box. The little right angle symbol. It's always shown to tell us it's a 90-degree angle. Then we have an obtuse angle. Obtuse angle is going to be greater than 90 but less than 180. And then the last one is a straight angle, which means it forms a straight line and it has a degree measure of 180. So opposite rays form a straight line, therefore they would be 180 degrees. Any line would be 180 degrees. But we call that a straight angle. All right, so let's take a look at our protractor. For those of you who don't know how to use a protractor, usually there's a hole in here. You can't see it as well, but this is where you put the vertex of your angle. And then you'd line up the 0 line on one of your rays or one of your sides of your angle. And then you would measure it, if you started over here on the right, if one of your sides was over here on the right, you use the numbers on the inside, and if it was over here on the left, you would use the numbers on the outside to find the angle measure. Now, because this is stationary, we're going to have a couple different types of questions here on how we're going to use this. So let me go back and get rid of that thing. All right, so the first one, we need to classify it as acute, right, obtuse, and straight, and then we're going to find each angle measure. So the first one is angle LKN. So let's take a look and see where exactly is angle LKN. So we have L, goes down a little bit, we have K, and we have N. So L comes down here. We started in, so it starts at 0. That means we should be able to use the inside numbers and find out where we're at. Now, because this is greater than 90 but less than 180, this is an obtuse angle. And our angle measure is going to be found somewhere between 140 and 150. So we say that's a little mark right there is halfway, so we say this is 145 degrees. Now, let's take a look at the next one, angle JKL. Now this one, J, K to L. Notice here that it's not starting at 0. So the measure of JKL is referring to this, how many degrees this is opening up. So let me get rid of this one here so that doesn't confuse us any. And we're looking at how far is it from here to here. Okay, so in this case, this can work just like a number line. We have numbers on each side. We need to find the distance between them. How far is it opening up? So you can have two choices. You could go from the inside numbers and use those, or you could work with the outside numbers, and you're going to get the same result. So I'm going to show you both ways. But before we do that, let's classify it here. We know it's smaller than 90, so that's got to be an acute angle. So we say this is acute. And the next thing we're going to do is find this. So I'm going to use the outside numbers first. So I'm going to say that the biggest number here is 90, the smallest number is 35. So I'm going to do 90 minus 35. That's going to give us a measure of 55 degrees. That means that our measure of JKL is 55 degrees. Now the second part, it'll say I use the inside numbers. Well, now my biggest number is 145. So I take 145 and I'm going to subtract the smaller number, which in this case is 90, and that also comes out to be 55 degrees. So from time to time, you may have to subtract inside angle measures for the protractor. So if you did the same thing, if it was angle LKM, you'd have to subtract from 145 over here to 35 over here and get your result, or from 35 here to 145 here. So you still get the same answer, but you just two ways to work it and two ways to approach it. All right, so now the last one here. The next angle measure is angle J, K, and N. So if you look here, J to K to N, this one has a side of the angle measure starting at 0, goes all the way up to 90, so this means it's going to be a right angle. And we know right angles have measures of 90 degrees. All right, let's move on to congruent angles. So like congruent segments, we also have congruent angles. Congruent angles are marked by a little small arc. If you have only one angle pair that are congruent, you're going to have just one. If there are two separate angle pairs congruent, you'd have two arcs. And three angles, you'd have 3 arcs. Typically, we don't have more than that. We may have 4, and we may have 4 arcs. But if we had the angle measures here, if we said they're both 30, we'd say the measure of these angles are equal. Okay, or if we just know that the two arcs are congruent, like so, if they're marked like this, then we say that they are congruent. So angle A would be congruent to angle B. Now we can call these angles by their vertex because there's only one angle at this vertex. Now let's look at the angle addition postulate. This one's very similar to the segment addition postulate. If point B is on the interior of angle AOC, the entire angle, then the measure of angle AOB plus the measure of angle BOC is equal to the measure of angle AOC. So if this was 90 degrees, or let's say it's a little bit bigger than that, we'll say 95. And we say this is going to be, say, 40 degrees. Add them together, that's going to give us 135 degrees. These two angles together should put together to equal 135, all the way from here to here. Now, if I took out one of these, if I told you the whole thing was 135 and I took out 95, you'd have to subtract to find out that this was BOC would be 40. So that's how the segment addition, or the angle addition postulate works. Very similar to the segment addition postulate. So let's look at example 3A. Measure RQT, this is a Q, is 155 degrees. So the whole thing is 155. What is the measure of RQS and the measure of TQS if this is equal to 155? So these two are going to add up to equal 155. So we'll take angle RQT equal to, we'll say angle RQS plus angle TQS. Now you could have put the RQT over here, it doesn't matter. We're going to plug in 155. So we put this over here just to change it up a little bit. RQS is 4x minus 20, and TQS is 3x plus 14. Combine like terms, so 7x in the x's, and with negative 20 and a positive 14 is a negative 6. We're going to add the 6. That gives us 161. And after we divide by 7, that's going to give us 23. So then we have to make sure we answer the question. It says find the measure of RQS. So angle RQS is equal to 4 times 23 minus 20. Okay, so 4 times 23 is going to be 92 minus 20, which gives us 72. So 72 is RQS, so this would be 72. And this one over here, angle TQS, this is going to be 3 times 23 plus 14. It looks like I didn't add this one correctly. So let's take a look at this again. Add this together. Excuse me. This should give me, what, 72? Yeah, that's right. So we get 3 times 23, which will give us 69, and then add 14. And 69 plus 14 is going to be 83. And so you can check it, check your two answers by adding them together and make sure they come up to be 155. So, always look for key words to help kind of figure out how to set the problem up. And if they give you two angles and tell you what the whole angle is equal to, you're going to set it up just like we did and solve it for the variable and then plug it back in. But in part B, they tell us that angle DEF is a straight angle. What are the measures of angle DEC and the measure of angle CEF? So a straight angle, which we've talked about before, is like a straight line. Straight angle has a measure of 180 degrees, which should tell you how to set this up. So try it on your own, pause the video, and come back and check it when you're done. All right, let's see how you did. So we talked about the DEF being a straight angle, therefore it means it should equal 180 degrees. So our first expression, our angle 11x minus 12 plus 2x plus 10 should equal 180, straight line. So if it said that this was opposite rays, if it said angle DEF, or if it said ED is an opposite ray of EF, then it tells you it's a straight line. It's going to equal 180. So always look for those type of clues. So now we get 11x minus 12 plus 2x plus 10 equals 180. 11x and 2x gives us 13x. Negative 12 and a positive 10 gives us negative 2. Begin by adding the 2 to both sides. 13x equals 182, and after you divide by 13, that gives us 14. So once again, make sure you follow the directions, plug it back in. 11 times 14 is 154 minus 12, which gives us 142. And then CEF is this angle over here, so this is 142. And then CEF is going to be the angle over here, which comes out to be 38 degrees. 2 times 14 is 28, plus 10 is 38. All right, so if you missed anything, always go back and rewatch it, fill in any notes that you missed, and that concludes lesson 1.4.